Hi everyone. Today we're going to be talking about systems of quadratic equations and how to solve them. So a couple of lessons ago we talked about just systems of linear equations, and we learned 3 different ways to solve them by graphing, substitution, and elimination. And you can actually use all 3 of those with quadratic equations as well. But the graphing part sometimes gets a little bit hard, mostly because we're throwing x squareds and y squareds at you. And so I'm going to show you how to solve all of these with substitution and elimination, and it kind of depends on the way that they look to whether you're going to use substitution or elimination, but you can use both of them to solve these. So let's just get started with the examples and go from there. All right, the first example is negative y squared minus 11x plus 3y minus 38 is equal to 0, and x plus y is equal to 1. So in this case, we have a quadratic formula, or a quadratic equation, which is on the top, and then a linear equation, which is on the bottom. The difference between quadratic and linear when you're looking at them, quadratic equations have exponents, have squareds, whereas linear equations don't. So when you have a quadratic equation and a linear equation, it's easiest to use the substitution method, where you solve one of the equations for a variable and then plug it into the other equation. So in this case, what we're going to do is use the linear equation, that bottom equation, x plus y is equal to 1, and solve it for one of the variables. It's going to be easiest probably just to solve it for y, and then what we'll do is take that and plug it into the top equation, into our quadratic equation. So to solve this for y, I would subtract x from each side, which would give me that y is equal to negative x plus 1. Okay, so now that I know y is equal to negative x plus 1, what I'm going to do is take that top equation and replace all of my y's with negative x plus 1. So I'm going to say negative, but instead of saying y, I'm going to say negative x plus 1. Notice that I put it in parentheses, squared, because we want to make sure that it's not just x squared, it's not just 1 squared, it's negative x plus 1 squared. Minus 11x plus 3, but instead of saying y, I'm going to replace it with negative x plus 1 minus 38 is equal to 0. Now we have one equation with one variable in it. They just all have x's. So what we can do is actually go through and solve this for x now. The way that we're going to do that is first by simplifying, getting rid of the parentheses. So it has a squared up here in the very beginning, which means I can write this negative x plus 1 out twice. Minus 11x. And then this 3 right here gets distributed inside. So it's going to end up being negative 3x plus 3 minus 38 is equal to 0. I'm still going to get rid of the parentheses up front by foiling. So we're going to do negative x times negative x and make all of the different combinations we need to. So negative x times negative x gives me x squared. And don't forget that there's that negative right in front. So I've got to still keep it in parentheses one more time, then we'll distribute the negative after we foiled. And then negative x times 1 gives me a negative 1x, or we can just say negative x. 1 times negative x gives me another negative x, and then 1 times 1 gives me 1. Now I'm just going to rewrite everything else that we have. Then from there, we're going to distribute the negative sign. The negative, all it does is just flip-flops all of the signs. So we're going to have negative x squared plus x minus 1. And it only flip-flops the signs inside the parentheses, so everything else stays the same. Now from here, we can combine like terms. So I have a negative x squared, and then let's do the x's. So I've got x, negative 11x, and negative 3x, which gives me a negative 12x when I add all of those together. And then we're going to do the things without x's, which are negative 1, 3, and negative 38. So which would give me negative 36 is equal to 0. From here, what we can do is we can actually factor this. The first thing that I noticed, though, is all of these things are negative. I really don't like when my x squareds are negative. It makes it a little bit harder to factor. So what I'm going to do is just multiply everything by -1. And as long as I multiply both sides by -1, it doesn't change anything. So when I multiply both sides by -1, all it does is flip-flop all of the signs. So I'm going to pop up with positive x squared plus 12x plus 36 is still equal to 0, because 0 times -1 is still 0. From here we can factor. I'm going to use that box method that we've talked about, where we have the x squared up here, the 36 down here. We're trying to find two numbers that multiply to be 36 and add to be 12. Those numbers are 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. So I'm going to have a 6x, 6x. The bottom two boxes have a 6 in common. The top two boxes have an x in common. The left two boxes have an x in common, and then the right two boxes have a 6 in common. So my factors are x plus 6 and x plus 6, which means I can write it in factored form like this. Then from there, we can actually set both of those equal to 0. So I'd have x plus 6 is equal to 0. And I would also have another x plus 6 is equal to 0, but we know they're going to give us the same answer because they're the same equation. I'm going to subtract 6 from each side, and I end up with x is equal to -6. So now I know x is equal to -6. That's great, but unfortunately, I'm not done yet because this is a system of equations. I have my x portion, but I still need my y portion. So I need to figure out what y is equal to. But this is going to be pretty easy because what we need to do now is just go back to one of our original equations and plug in what we know x is for y. So I'm going to actually take this this equation that we set equal to y is equal to -x plus 1, and replace the x with -6. So I'd have y is equal to -6 plus 1, which is the same thing as saying y is equal to 6 plus 1, because those negatives, it's a double negative which cancels itself out, which tells me that y is equal to 7. So I know that x is equal to -6 when y is equal to 7. So my final answer in point form would be -6, 7. Okay, so in that example, we only had one solution. We had an x and a y. Now, sometimes you end up with multiple solutions, like multiple points that are solutions. And so let's take a look at one like that. The second example is x squared plus y squared minus 7x plus 3y minus 28 is equal to 0, and then -2x plus y is equal to 4. So once again, we have a quadratic equation and a linear equation. When you have one quadratic and one linear, it's easiest to solve the linear equation for one of the variables and then plug it into the quadratic equation. So I'm going to take this one and solve it for y again. To solve it for y, I would add 2x to each side, which would give me y is equal to 2x plus 4. Now that I know that y is equal to 2x plus 4, I can replace all of the y's in my top equation with 2x plus 4, which gives me x squared plus, instead of y, I say 2x plus 4 squared minus 7x plus 3, 2x plus 4 instead of y, minus 28 is equal to 0. Now we're going to simplify that, which would give me x squared plus the 2x plus 4 squared I write out twice, minus 7x, and then we're going to distribute the 3, which gives me 6x plus 12 minus 28 is equal to 0. Now we're going to FOIL the parentheses, so you make all of those different combinations. So we have x squared plus 2x times 2x gives me a 4x squared. 2x times 4 gives me 8x. 4 times 2x gives me an 8x, and then 4 times 4 gives me 16. Then we're going to just rewrite the rest of the equation. All right, now we're going to combine like terms. So I have an x squared and a 4x squared, which gives me 5x squared. Then for our x's, we have 8x, 8x, -7x, and 6x, which gives me, let's see, 15x. And then we have 16, 12, and -28. When we add all of those together, we end up with 0. So I could potentially put like a plus 0 at the end, but plus 0 doesn't change anything. So I can just kind of ignore the plus 0 and set it equal to 0. Okay, so from here, now we need to solve for x. here's the deal. We haven't looked at one of these too closely, but when you don't have a constant term, a lot of the times you can factor it by looking at it and saying, what do they both have in common? So in this case, both of these terms have a 5x in common. So what I'm going to do is factor a 5x out, meaning I'm going to divide each chunk by 5x. So 5x squared divided by 5x gives me just an x, and then 15x divided by 5x gives me a 3. And so these are the factors, or this is just another way of writing it, but now it's in this factored form. I can actually set both of these chunks equal to 0. So I can say 5x is equal to 0 and x plus 3 is equal to 0. And then I solve both of those. I'm going to divide this one by 5 on each side. I end up with x is equal to 0 because any 0 divided by anything is 0. And then on the right side, I subtract 3 from each side. I end up with x is equal to negative 3. So now I have two solutions for x. I have x is equal to 0 and x is equal to negative 3. This is great. Now that I have two solutions for x, I can solve for y. I'm going to go back up and use this equation right here, y is equal to 2x plus 4, and actually replace the x with both of those numbers, just one at a time. So I'm going to plug in 0 first. I'd have y is equal to 2 times 0 plus 4. The other equation would be y is equal to 2 times negative 3, because that's my other solution for x, plus 4. So when I plug the first one into into my calculator, I should end up with 4. And then when I plug my second one into the calculator, I should end up with negative 2. So these are my two solutions for y. Now we can't just write them out like that we have two solutions for x and two solutions for y. We have to put them in points. The reason why we put them in points is because the solution of x is equal to 0 gave me the solution y equals 4. So I can't put it with a different answer for y. You have to keep the solutions together that should stay together. So my two final solutions would be 0, 4 from the first point, and then negative 3, negative 2 from the second point. And so this example had two solutions. Okay, cool. So now we've talked about how to do solving systems with substitution. Now we're going to talk about how to do it with elimination in the third example. So the third example is y squared plus x minus 14 is equal to 0. And then 6y squared plus x minus 59 is equal to 0. So both of these equations are now quadratic. When you have two quadratic equations, it's easiest to solve this with elimination. So when we do elimination, the goal is to get rid of one of the variables. And what I like to do is I like to look for the ones that look really like similar already. So if you look, both of these equations have a positive x in them. So what I'm going to do is I'm going to take this bottom equation and multiply it by negative 1. The reason why I'm multiplying it by negative 1 is because I want them actually to have the opposite sign so that when I add them together, they cancel out. So I'm just going to rewrite my equations, but rewrite that bottom equation after multiplying by negative 1, which just flip-flops the sign, so it ends up being negative 6y squared minus x plus 59 is equal to 0. And then we're going to add those two things together. Now, let me backtrack and say this. This is a rule of elimination, but as long as I multiply the entire equation by negative 1, it doesn't change the value of anything. So I multiplied everything by 1. I multiplied both sides of the equal sign by negative 1, but 0 times anything is 0, so it didn't change that value. But we had to multiply everything and switch the signs on everything in order for it to keep the equality. So now we're going to add these equations together. We have 6y minus 6y squared, which would give me a negative 5y squared. Then we have a positive x and a negative x, and those two things cancel each other out, and that's what we wanted. And then we have a negative 14 and a 59, which when we add those together, we get 45, and that's equal to 0. Now we have one equation with one variable, which is awesome. So to solve this now, what we're going to do is get the y squared by itself by subtracting 45 from each side. So we get negative 5y squared is equal to negative 45. Then we're going to divide each side by negative 5. We get y squared is equal to 9. It's a positive 9 because a negative divided by a negative is a positive. And then I want to get rid of the squared. To get rid of the squared, I square root both sides. And remember, when I square root both sides, or when I square root a number, I have to make it plus or minus. So it ends up, like I have to put a plus or minus right there. So I end up with y is equal to, the square root of 9 is 3. So it'd be plus or minus 3, which means I have two solutions for y. It's either positive 3 or negative 3. Great. Now that we know what y is, let me box that up so that we kind of remember that. What we're going to do is go back to one of our original equations and plug both of those options in to solve for x. So I'm just going to take that top equation, which is y squared plus x minus 14 is equal to 0. And we're going to replace the y with a positive 3. And then we're going to replace it with a negative 3. And solve both of these for x. So on the positive 3 side, 3 squared is 9, plus x minus 14 is equal to 0. I'm going to combine like terms with the 9 and minus 14, which gives me x minus 5 is equal to 0. Then I can add 5 to each side, and I end up with x is equal to 5. So that's great. And then for the right side, we have negative 3 squared, which also gives me 9. Because a negative times a negative is a positive. We combine these two like terms, which once again gives me x minus 5 is equal to 0. I add 5 to each side. I end up with x is equal to 5 again. So even though you got the same answer for x, you still have two solutions for y, which means overall my two solutions would be, I was going to put my y's first. So it would be 5 comma positive 3, because we have to put the x's first. Or 5 comma negative 3. And those are my two solutions. Okay, so let's go over this last example. The last example is 5y squared plus 16x plus 20y plus 36 is equal to 0. And 3x squared plus 5y squared plus 5x minus 20y minus 18 is equal to 0. Okay, so the first thing I notice right off the bat, oh, you know what? Let me check something really fast. I believe that this should actually be a minus sign. Yeah, that should be a minus sign. Okay, sorry about that. So notice that we have a positive 5y squared on the top and a negative 5y squared on the bottom. We also have a positive 20y on top and a negative 20y on bottom, which is great because what we're going to do, like we don't even have to multiply anything to each other, like multiply any of the equations by -1 or by a number. We can actually just add these together and get some stuff to cancel out. So when we add these together, it's a little bit scawampus, but you want to add like this 5y squared to the negative 5y squared, basically combining like terms. So this 5y squared will cancel out with this 5y squared because one's positive and one's negative. But we do have the 3x squared. There's no other 3x squared to add to it, so we just leave it 3x squared. Then we have a 16x and a 5x, which will give me 21x. And then we have 20y and negative 20y. Those two things cancel each other out because one's positive and one's negative. And then 36 and negative 18 gives me a positive 18 when I add them together, and that's equal to 0. Okay, and the first thing I notice on here is we got rid of our y's, which is perfect. We wanted to get one equation with one variable. We succeeded in that. Now to solve for x, the other thing that I notice is that all of these things are divisible by 3. So I'm just going to divide everything by 3. And I end up with x squared plus 7x plus 6 is equal to 0. From here, and I can divide everything by 3 as long as I divide all sides by 3. And remember, 0 divided by anything is just 0, so 0 divided by 3 is still 0. From here, I'm going to use the box method to factor this. So we have x squared, 6. We want to multiply to be 6 and add to be 7. That is 6 and 1. So 6 plus 1 is 7. 6 times 1 is 6. So I have a 6x and a 1x And what do the bottom two boxes have in common? They really don't have anything in common, so we put a 1. The top two boxes have an x in common. The left two boxes have an x in common, and then the right two boxes have a 6 in common. So I can rewrite this equation as x plus 1, x plus 6 is equal to 0. And then because it's in factored form, we can set each chunk equal to 0. So we have x plus 1 is equal to 0, x plus 6 is equal to 0. And I subtract 1 from each side over here. I get x is equal to -1. And then I subtract 6 on this side. And I end up with x is equal to -6. So these are my two solutions for x. Great. Now we actually have to solve for y. So to solve for y, we're going to plug our x back into one of the original equations. And I'm just going to take that top equation. So I'm going to rewrite it 5y squared plus 16x plus 20y plus 36 is equal to 0. And I'm going to just start with, we're going to do one at a time because these ones will end up being a little bit more complicated. But I'm going to start with the -1. So I'm going to replace the x with -1, which gives me this equation. And then when we know 16 times -1 gives me a -16, right? So now we're going to combine like terms with the -16 and the 36, which ends up giving me 5y squared plus 20y plus 20 is equal to 0. The thing I notice about this is that they're all divisible by 5. So I'm going to divide everything by 5, which would give me y squared plus 4y plus 4 is equal to 0. Then I can do the box method for this. So we have a y squared up here, 4 down here. We want to multiply to be 4 and add to be 4, which ends up being 2 and 2, because 2 times 2 is 4, 2 plus 2 is 4. So we'd have 2y, 2y. The bottom two boxes have a 2 in common. The top two boxes have a y in common. The left two boxes have a y in common. And the right two boxes have a 2 in common. So I can rewrite this as y plus 2 times y plus 2 is equal to 0. And then because they're in factors, now I can set each of them equal to 0. But because they're the same factor, we can just set one of them equal to 0. So we'd have y plus 2 is equal to 0. Then from there, we're going to subtract 2 from each side. We end up with y is equal to -2. Okay, great. So that is attached to the x is equal to -1, which means one of my solutions is -1, comma, -2. Now we've got to find the other solution. And for that solution, what we're going to do is, let's see, we're going to take that equation, this equation right here, and we're going to replace the x now with -6. So I'm going to have, let's see, so we're going to say 5y squared plus 16, but instead of saying x, I'm going to say -6 plus 20y plus 36 is equal to 0. 16 times -6 gives me -96, and so I'm going to combine the -96 and the 36 to get 5y squared plus 20y minus 60 is equal to 0. They're still all divisible by 5, so I can divide everything by 5. We get y squared plus 4y minus 12 is equal to 0, and then I can put that in the box method to factor. I want to find something that multiplies to be -12 and adds to be 4. So in this case, it's going to end up being 6 and -2, because 6 times -2 is -12, and 6 plus -2 is a 4. So I'm going to put a 6y in one spot, a -2y in another. The bottom two boxes have a -2 in common. The top two boxes have a y in common. The left two boxes have a y in common, and then the right two boxes have a 6 in common. And so my factors would be y minus 2, y plus 6 is equal to 0. Because they're in factors, I can set each of them equal to 0. And then to solve those, I would add 2 to each side. I get y could be equal to 2. I would subtract 6 from each side. I would get y is equal to -6. So these are my two solutions for when x is equal to negative 6. So I'm going to scroll back up here. Remember, we had this one solution, negative 1 comma negative 2. So I'm going to just write it down right here, negative 1 comma negative 2. And then I have two other solutions that come from when x is negative 6. So I'm going to have negative 6 comma 2 from right here, this y is equal to 2. And then I'm also going to have negative 6 comma negative 6, because when I plugged in negative 6, I got two solutions for y. And there we have it. That is how we solve systems of quadratic equations.